Okay, dear students, so let's see what is there in this question. An ideal gas is held in a cylinder by a piston. The piston compresses the gas rapidly. The average speed of the gas molecules increases because the gas molecules. So what happens in this process is gas molecules are getting heated up, and more is the temperature, more becomes the average kinetic energy of the molecules. And so we can clearly say that the average speed of the gas molecule will increase. So actually the temperature of the gas is increasing. Okay, so before even moving into the options here, let me explain this process a bit more. See, in this question they have not written whether this is an adiabatic process or whether it is what. Let me explain you that. It's complete, like it's a bit details we have to go here, but it is very important. This wall is not shown as the adiabatic wall, by the way. The compression is taking place and work is done on the system by the external agency because compression is taking place. And of course there is a chance that it could be isothermal process or it could be an adiabatic process also. Let me explain. It could be isothermal if the temperature is supposed to be remaining constant. Now the walls are not adiabatic wall. Adiabatic wall is shown as thick walls like this. This is the adiabatic wall, but they are not showing this container with the adiabatic wall. So these are not adiabatic wall. But there is something written in the question. The piston compresses the gas rapidly. So when this word is written like rapidly, it means that the process will be treated as adiabatic process. Why so? Because the process is happening rapidly means that the gas in the container, it is heating up, but it is not having that much of the time so that it might be able to transfer heat to the surrounding. So the transfer of the heat is actually not happening because the process is rapid, not because the walls are adiabatic, but because the process is rapid. So be very careful about it. Because the process is rapid, we are going to treat this as adiabatic process. Now, what happens in adiabatic process? The delta Q is taken to be zero. And let me write the first law of thermodynamics and explain a bit more. Delta Q is equal to delta U plus delta W. Now you see, delta Q is zero, delta U and delta W. So the change in internal energy will be the negative of the work done. Work done is P delta V, we all know. So that is negative of work done. Now the work done is on the system. That is why work done is negative. It means overall this expression will give you a positive value, which means that there is going to be an increase in internal energy. So change in internal energy is positive, means that the final internal energy is more than the initial internal energy. And internal energy is only and only depending on temperature. We have done every of this thing in the topic B3 and B4 taken together, if I say. So the internal energy is increasing here, which is Cp delta T, Cv. Okay, don't be concerned with that. So internal energy is increasing, so the temperature is increasing. So this is the whole process. Now we are moving into the options. Have a smaller volume available in which they can move. That doesn't make any sense. Receives thermal energy transferred from outside. No. Why? Because it will be behaving as adiabatic process because the process is rapid. So that is not going to happen. Receive energy from piston as they collide with it. I don't believe so. And make more collisions every second with each other. No, no, no. Absolutely, C will be the correct answer. Now listen to me. Receive energy from the piston as they collide with it might be that they're referring to the work done by the piston. So when the piston is moving here, work is done by the system, by the piston on the system. So work is done on the system. We can say that yes, the energy is received from the piston as they collide with it more often now. So indirectly, we can say that the work done by the piston on the system is converted into internal energy, and that is why the internal energy is increasing. This is the complete scenario of this question. I have tried to give you the answer for this, incorporating all the thermodynamic principle, the B4 principles, which is now in your syllabus. Earlier it was not, but now that has been added. So I have incorporated all of that. So the answer for the question number 12 will be C. This is Professor Varun. Thanks for watching the video. Keep watching other questions.